welcome back to the Mycoal tutorial. It's Wednesday at 3 AM, and in this video I'll be talking about the Epsilon-Greedy policy in reinforcement learning. When you're training an AI agent, there's one big question. Should you make the AI try something new, or just stick with what it works? This is called the exploration versus exploitation dilemma, and the simplest way to handle this is something called Epsilon-Greedy policy. Let me show you how it works with an example. Say there are 3 treasure chests in front of you. Each chest gives a different reward when open. One chest gives 1 coin, one gives 5 coins, and one gives 10 coins. These coins represent the reward the agent gets from choosing the action. And let's just say, the way the agent understands which chest is the best is by an input state. Let's say for example, we give it 1, 0, 0. This means that the best chest is the 1 spot, and the other 2 chests are 0, which means in the 2nd and 3rd slot. If we do 0, 0, 1, that means the best chest is going to be in the last slot, and the other 2 chests are going to be in the other 2 slots. The AI, our agent, gets this input state and has to choose a chest based on the input state, and this is what we call the action. That means the AI has 3 input states and 3 actions. Over time, it should realize which chest to choose from based on this inputs layer. But learning this pattern requires trying out different chests, even if they don't always work out right away. So let's say for example, we don't use Epsilon-Greedy policy. Early on, the agent, let's just say, just gets lucky by choosing the 5 coin chest in the first slot. Getting this 5-point reward, it keeps opening that chest every single time but never tries the other 2, because all it knows is that the 5 coin chest is going to be on the first one. It never discovers the 10 coin chest even when the hint points to it, because it never understands. It gets stuck in a quote-unquote good enough loop and never learns the full pattern. However, with using Epsilon-Greedy policy, instead of always going for the best so far, the agent chooses a random chest occasionally based on the epsilon value. We can call epsilon a percentage. So say for example epsilon is 100%, that means 100% of the time it will choose a random action. If epsilon is 50%, 50% of the time it will choose a random action, and 50% of the time it will use its neural network to figure out which action it should use, which gives the best reward that it knows of. This given randomness helps it gather new information and learn faster instead of getting stuck on early guesses. However, how do we know when to decrease this epsilon, that way it can use what it knows best? This is what we call epsilon decay. At first, we usually make the agent explore a lot with a high epsilon, for example 1 or 100%, which makes it fully random. Over time, we decrease epsilon by giving constant value, eventually down to something like 0.1 or 0.05. Eventually, the agent mostly sticks with the best action because it now actually knows which is the best, because of the randomness. However, why do we decide to keep it at 0.1 or 0.05? Even after an agent thinks it has learned the best policy, it can either get stuck in a local optimum, overfit to noisy experiences, or mess out on better strategies. So we keep a small epsilon so that way it keeps exploring a little bit. Here's a real world example. Say you've been going to the same restaurant for months because you like the food a lot. However, let's just say every 10 or 100 days you go visit a different restaurant. You could find something better. This tiny bit of exploration keeps options open and could eventually lead you to better results in the future. The Epsilon-Greedy policy helps an agent choose actions based on the input state by usually picking the best known option, but occasionally exploring others at random. This balance helps the agent learn the true relationship between the inputs and the rewards instead of getting stuck too early on. If you found this video helpful, please leave a like, leave a comment of what I could do better, and thank you for watching.